What's up, everyone? Today we're going to do a problem where we're going to try and find the longest common substring between two different strings. So basically, that's exactly what it sounds like. If you have, for example, we have here two strings ABAB and BABA. And obviously, in this case, there are two substrings that are equally long. There's this ABAB, and there's also BABA. BAB, sorry. And so we are just going to return one of those. And so let's just jump right into actually trying to solve this question. But first, we need to ask some questions of our interviewer. And a couple good questions to ask would be, for example, what is the actual character set that we're using in this problem? Because in this example, I used all caps, for example. And we don't know if we're going to use all sorts of characters. What if we have uppercase and lowercase characters? Are those the same? If they're the same character, do we have to deal with that? And that's something that we want to ask our interviewer because it's something that we want to make sure that they know that we're thinking about. So in this case, I'm going to simplify it a little bit and just say that I want to use exactly the same characters. So for example, these have this common substring, but if I changed it to this, then there would be no common substring, and the result would just be the empty string like this. So that's just going to make it slightly simpler, but obviously, if you didn't do that, all you have to do is just convert everything to lowercase or uppercase before you do it. So just things to think about. And something else that we might want to think about is what is going to be the length of the strings that are going to be our input. So we'll get to this in a minute, but we're probably going to use some sort of dynamic programming to solve this. And the length of the strings are going to make a big difference. Because if the strings are really long, then that means that we're going to have to cache a lot of data. And we're going to need to think about how we can optimize how much data that we're actually using. So we need to, by asking just like they're not going to tell you the strings are going to be this exact length, but you can get a sense. Are they going to be 100 characters, or are they going to be 1,000 characters? Or are they going to be 10 or 100,000 characters? So just getting them to give you a sense, and maybe they'll just say, oh, well, it has to work for all strings, and then you can assume that the strings might be really long, and you'll want to think about how you can optimize. And even just having a discussion with your interviewer about why this makes a difference is a really good thing. So that's something to think about. And the last thing that we want to think about is just how we're going to treat the case if we have multiple max length substrings. So in this example, obviously we have the BAB and we have the ABA. And I've decided that I'm just going to return an arbitrary longest substring, and it doesn't really matter, but you want to check with your interviewer if they want you to specify which string they actually want you to return. So things to think about. So let's think about how we're actually going to solve this. And the first thing that we could do is obviously we could do a brute force method. So we could, and this is going to be fairly simple example because these strings are very short, but we'd just have two pointers, and we'd have 2 pointers for each string. So we would have 2 pointers here and 2 pointers here. And we would just go through all possible substrings. So, we're going to increment this one, and then we're going to increment this one like this, and so on and so forth, go through all substrings, and then we'd come back to the beginning, and we'd do the same thing again with this string, and we'd go through every possible substring. And obviously this is not an efficient approach. So, but it's a good way to think about, even just mention that this is a possible approach, because there are cases where the brute force method is the best way to go, and it's a good way to start your thinking. And another option that we could use would be a try, right? Where we would basically be putting one of these strings into a try that would basically store all possible substrings. And we would do some sort of tree or try of all the substrings of a given string, and then we would go through our other string and we would try and find how the longest substring in that string that was present in that try. So that's a decent way to do it as well. But I think that the simplest way, that's going to be a little bit of a pain to implement. And I think that the simplest solution for us is going to be to do some sort of pre-computation / dynamic programming. So what I'm going to do is I'm going to pre-compute for every possible combination. So I'm going to pre-compute what the maximum substring is at each point. So I'm going to have these two strings, and I'm going to go through with 2 pointers, one for each string, and I'm going to say, okay, so what is the longest common length substring here? And the answer is obviously 0 because there is no substring, but then I'm going to increment this by 1, and I'm going to say, okay, what's the longest common substring here? And the answer is 1 because they're both equal. And now I increment to here, and it's 0, and here it's 1. And then I'm going to come back to the beginning, and I'm going to increment this by 1, and now I'm going to say, okay, the longest common substring here between these two is 1, and now the longest substring is 0, and now it's 2, right? Because we have that this is like the end of the string. And so to be able to visualize this a little better, I made this 2D array, which is basically how we're going to represent it in our code. So what you can see here is that these represent the longest substring terminating at a given point. So we have our one string here and our other string going vertically here. And so obviously the first one is 0, and then this is the string AB and the string B. And so the longest common substring is 1. And this is the string AB. Here it's ABAB and B. So the longest substring is 1. And then let's say we come down here, we have ABA and BABA. So obviously the longest substring terminating there is ABA, which is of length 3. And so by doing this, we can see that we're going to basically go through and pre-compute everything. And this also, so that once we actually get to the end, we're going to have all this, and it's going to be easy for us to just get the longest substring out of our data. And the other thing that you'll notice here is that follows this progression here, where this is 1, 2, 3, this is 1, 2, 3 here. So this is hopefully obvious how this is going to lend itself to dynamic programming. Because what we're going to be able to do is we're going to be able to go through and build this up. We're going to start with an array. So if we just copy this here, we're going to start with an array that's all going to be zeros. So just like this. And 0. And then what we're going to do is we're going to have our 2 pointers like we had before. So if I copy those down here like this, we're going to start with the pointers at the beginning, and this is going to represent this first cell. And so we're going to say that's 0, and then we're going to increment this, and now we're here. So this is equal to 1. And we go on until we get to here, which is this cell here. And now we know that since this previous one was a substring, so here was a substring, then since this is also a substring, it's going to be a 1 longer substring. So we're actually going to get this value, and we're going to just add 1 to it, and that's how we're going to compute the longest substring at a current cell. So in a different case, so let's look at this example where we're at this cell here, then there was no common substring here, and there's still no common substring, so we're not going to do anything. And then in this case, for example, there's a common substring starting here, but this is the beginning of the substring. So since we know that we're at one of the edges of this array, basically, we're going to go ahead and start it at 1. We're going to say that our initial value is 0. So hopefully that makes sense, but I'm just going to go ahead and jump right into the code because I think that that's going to make this a little bit more clear. So we're going to create a class and I'm going to call it Substring, and it's going to return a string. I'm actually going to call it longest substring. And it's going to take in two strings A and B. Just like that. And so the first thing, just a small optimization we can do is that we are going to, if either string is of length 0, then we know that the longest common substring is of length 0 as well, or is the empty string. So I'm going to go ahead and, well, I'm going to have this out variable that's going to start as the empty string. And if either input string is 0, I'm just going to return that. So if a.length equals 0 or b.length equals 0, return out. And the reason why I have this here is that I'm going to use this later to store the current longest substring as we're computing, and I just think it's slightly cleaner to do that than to reiterate the empty string here, but you can of course do whatever you prefer. Then we're going to save, we want to know what the current length is, so or actually we don't even need to do that because we're just going to get the length of our output string. So we'll just create a cache here. And I'm going to use a 2D array, which is not the most efficient solution. And we can talk about why this is not the most efficient solution, because I think it's a useful thing to think about, particularly when I mentioned if you have a really long input string, this is something that you want to think about. So, but first we are just creating an array, a 2D array where our one dimension is the length of one string and our other dimension is the length of the other string, and that's going to give us this array like we have. But so let's think about for a second how we could optimize this. And I'm not going to do this because it complicates the code and it's an exercise you can do on your own if you want. But what you might notice here is that we're only referring to the previous single row basically, or the previous diagonal in our iteration. So we're going to go through our string like this basically. We're going to go through here and we're going to go through this way looking at the first column, and then we're going to go through this way looking at the second column, and so on. And you only need to store the most recent sort of row of the array because we're not actually ever going to refer, like this value doesn't depend directly on this value here. And we only need this value to calculate this value at any given time. So we don't need the whole array to calculate our next value. So we could get away with a single array of length, n plus m or something like that. And you can think about how you might implement that, and that might be a good exercise. But this is going to be slightly simpler, and I think it's slightly more intuitive because you can see it more clearly. So I'm going to do it this way, and just keep in mind that there is a slightly more space efficient way that you could do this. So I'm going to just iterate through both strings. So I'm going to do int I equals 0, I is less than a.length, and I plus plus. And then within that, we're going to go through the B string. So for int j equals 0, j is less than b.length, and j plus plus. So, okay, now what do we want to do in here? So the first thing that we are going to do is we're not going to do anything unless the two characters are equal, right? Unless the character at I in string A and the character at J in string B are equal, then there's no substring. So we are just going to only treat that one case. So if car a.car at I is equal to b.char at j. Right? So we don't want to worry about any other cases. And then the first thing we need to do is look at sort of our base case in this iteration or this dynamic programming where we're at the first row or the first column. And in either of these cases, we don't have a previous cell to refer to. And we know that if we're at the if either I or j is 0, it means that we're at the beginning of one of these strings. And so what that means is that the longest possible substring is of length 1. So we're going to say, and if they're equal, then there is a substring. So we're going to say if I equals 0 or j equals 0, then we're just going to add 1 to that cell in our cache. So we're going to say cache I j equals 1. And that way we're going to sort of kick off our process with the dynamic programming. And then otherwise, we want to calculate from the previous cell. So we're going to say that cache ij is going to be equal to cache of I minus 1, j minus 1 plus 1, right? So we're referring to if we are at this cell, so let's say we're looking at this cell here. We have the string AB and we have the string BAB. And so we want to see what the longest substring was when both of at the previous character in both strings. So we're going to get cache of I minus 1, j minus 1, and we're going to add 1 obviously because we have just found the next. We're basically, once we get to this point, we're moving in sequence with the two strings. So we just added 1 onto our longest substring. And then finally, what we need to do is we want to actually get if we just found a longer substring than our currently longest substring, we want to go ahead and get that. And this is going to save us. What we could do is we could just run all this computation first and then iterate through the array, find the longest or the largest value in the array, and then work backwards from there to get the substring. But it's going to be, I think, better to just do it here. So we can say if cache I j is greater than out.length, then what that means is that we have found a longer substring. We're going to just say that out is going to be equal to a.substring. And what we need to do, we're going to do I minus length, but then we need to do plus 1 here and I plus 1 as the top end. And the reason for the plus 1 is that we're sort of in this we're basically offset by 1. Because at this 0th element, we're saying that the substring length equals 1. And it's because each cell refers to the longest substring that ends at that point, or that has occurred already, inclusive of those last two characters. So you could basically offset this by 1, right? You could say that, this is 0, this is 1, and this is 2. And that would make this part slightly simpler, but I think it's slightly easier to think about it this way. Whatever you want to do is totally fine. And so this is just going to get us this is going to get us the substring. So let's say that we're here. We're going to get I minus 3. So we're going to do I is the index in this first string. So that's going to be, it's right now 2. So we're going to negative 1. And then plus 1 is 0. So we're going to go from here. And then I is 2. And that's going to be plus 1 is 3 because the substring goes from the first element inclusive to the second index non-inclusive. And that way we're going to get this substring. So let's go ahead, and the only other thing we need to do is just return our out string. And let's go ahead and actually test this and make sure that it does what we expect it to do. So I'm going to do it with an even simpler example than this one here because I don't want to spend so long doing it. So I'm going to do 0, 0, 0, and then this here. So 0, 0, 0. So we're going to get our string out is going to be equal to the empty string. Neither string's length is 0, so we're going to return out. We're not going to return out. We're going to create our cache, which is here. And so I equals 0 and I is less than. So let's say I equals 0, j equals 0. So j is, let's see. So car at 0, 0 is not equal, so we're not going to do anything. Then j we increment by 1, so we're going to have this here at this row, basically. So car at I0, j1 is equal, and I is equal to 0. So we're going to set this value equal to 1. And then cache I is greater, the length is greater, so we're going to set a.substring of I minus length plus 1, which is 1 minus, it's 0 minus 1 plus 1, which is 0, to 0 plus 1, which is 1. So that's just going to give us the one character here, which is what we expect. Then we're going to increment I. So I is now 1 and j is 0. So at I1, J0, we get that they are equal, right? Because we have B and B. And J is equal to 0 in this case, so we're going to set it to be equal to 1, like we did before. And then we're going to come down here, and the cache is equal to, the IJ is equal to 1, but the length of out is also equal to 1, so we're not going to do anything. And now we increment J. We get that these are not equal, so we do nothing. Then we're going to increment I again, j equals 0. So now we're here, and we don't have they're not equal, so we do nothing. And then we're going to increment j by 1. So now we're going to have so the characters are equal because they're both A. Neither I nor j is equal to 0. So we're going to come down here, and we're going to say cache ij equals cache I minus 1 plus j minus 1 plus 1. So I minus 1 is 1, which is this column here, and j minus 1 is 0, so we get this cell. And then we're going to set this one to equal to the previous cell plus 1. So we're going to set that equal to 2, and now we get caches longer than out.length. So we're going to set the out is going to be equal to a.substring, and I minus length plus 1 is going to be equal to 2 minus, so this should actually be cache ij, because that is the current length. So what we want is the length of this string, right? Because we're basically getting the offset that we're currently at. So we're going to get I, which is 2, minus 2 plus 1. So we're going to get I is 1, or this is going to be 1, and this is going to be I, which is 2, plus 1, which is 3. So we get from 1 to 3, which is here, and then there's 1 more off the end like this. And that's going to give us this substring, which is exactly what we expect, and we're going to return that. And so BA is our longest substring, and that's basically all there is. So hopefully that question made sense. It's a little tricky, but let me know if you have any questions down in the comments below or on the blog, and I will see you again soon.